presentation. So this is data analytics in an insurance company based on my personal experience. So I've been mostly in the tech space for most of my career, but it's here in the insurance company that I work with that I slowly got moved up the ladder, if you will. And one of the things that I wanted to put out there before I go to the main parts of the presentation is that one of the key mantras that I've had over the years, and even with the company that I'm with right now, is that if you define the problem correctly, you almost have the solution. I believe that's always the case with literally anything. I work with business analysts daily in my work as a data director. I work with data engineers, data analysts, data scientists, and even people from governance. And usually, as long as you have defined the problem, you're almost there. You get a sense of what you need to do. And so for insurance, when I joined, this is the same principle that I applied. And I asked the company, what are we trying to achieve? And what I found out in an insurance company is that it's mostly traditional. So what happens is you have a few databases here and there. You have a few systems that are not even modern, if you will. Some are still using tape, AS400 for folks here who are familiar. And then most of it is just all over the place. It's essentially, you have a copy of your customer information, your sales, in a bunch of systems with differing versions. So like when you need to do a report, when you need to analyze, did my company do well? What's my sales like? How am I gonna push forward? If it was just a few records, then great. But working with an enterprise, you have millions of records, and then you have to match that against a system that's largely different and reports a different number. So you see the problem there. The company wants to have proper analytics. The company wants to be able to use data as a way to propel us further into the future. But there's no way to see data in its proper form in an easy way. So what we proposed, or what I proposed, and I guess what got me promoted, is the single clean source of truth. I've been pushing for this for the longest time, in that we need a single space where data is easy to understand, it's accessible and reliable, cleansed on collection, and maintained regularly. And I want to point out cleanse on collection here, just because you can always clean the data after the fact, but it would be tedious, it would be expensive, and it would be essentially pointless if you could collect data clean from the start. So it's going to be not just a technical change, but also a process change. The people working on the front lines, the ones that are getting customers, selling to customers, they need to change the way they collect data. For most companies that are traditional, you're going to see a lot of instances where the front ends have free text as entry points for data. So like if you're asking for a date, for example, some people will just use the exact words, some people will use the number format of the date, and some people might even just type whatever they want in there. You can even do SQL injection if you want, just because the system is not proper. So we want a single clean source of truth where everything is cleansed upon collection. Once it gets to that single source of truth, it's already clean. And anything that goes beyond that, whether circumstantial or intentional, we can maintain regularly, we can clean regularly. So once you have that as a foundation, now you can do the analytics that the company wants. You can now have data on demand. There's four types of analytics that we know of so far, and I'm going to be talking about those later. But basically, for us in the insurance space, we're targeting the prescriptive type of analytics. We want to focus on the how. We want to have clear data storytelling on this, and we want to use it in making decisions. And then it's great that you have a single clean source of truth. It's great that you have analytics, but if you have no one using the technology and the solutions that you provided, it doesn't make sense. So on the side, we also are upskilling people. We're making sure all the visions are aligned. People know what they need to do, whether they're the data producer or the data consumer. We have a community mindset where you don't have to repeat everything. So in smaller companies, this is probably not a thing, but in large corporations where every division has its own reports, some of these divisions will create reports that are similar to another divisions, just with the minor tweak. And these are the kinds of things we want to avoid. We want to make sure that if your report kind of looks like mine, then maybe we should collaborate and build a single report rather than clutter, the report space. Because not having more analytics doesn't mean having more reports. And we want to make sure that data is prioritized. That's the one of the key things. Because right now, data really plays more of a second or third class citizen in most traditional companies. Moving on. I was talking about the single source of truth, and I want to present to you the idea of data democratization. So I don't know if anyone here is familiar with the term. Or maybe everyone is shy. But okay, data democratization, when you think about it, in most conversations, if you've heard about this, I'm sure you're gonna either think, or someone might have told you that you just provide the data to the people, right? You just make sure everyone has access to the data, and that's data democratization. But in reality, it's not just that. It's very easy to provide data, don't get me wrong. But making sure that the people that are getting access to the data actually know how to use the data is a different story. You can easily provide an executive with access to the database, and even if that executive wanted to expose data, do something bad with it, steal it or something, he probably couldn't, just because he doesn't have a way to use the data comfortably. So data democratization is actually a process of making sure that, yes, people are getting access, but also the people getting access are able to use the data in its form when it arrives to them. So that's one of the key things for us. On that, so we are currently building our data strategy roadmap. As mentioned, we're building towards a single clean source of truth. That's going to be the data warehouse that we're building on the left side of the screen. Once we have a sense of the overall landscape for us, we're going to be moving all of this into our cloud instances. We're going to be acquiring Azure Data Lake Storage. We're going to put up our data there and then open it up for the business users to start their data science and machine learning, to build their reports and data marts. And if you guys are familiar with the data lake, it also opens up opportunities for unstructured data. So there's two types of data: structured, wherein it's in a form that's easily readable by computers and machines, and then unstructured data, where you have your pictures, your emails, your PDF, your scans, all of that. So we want to be able to maximize usage of data for our analytics. And then moving from that, we're looking to go to a data lakehouse approach, wherein data is now streaming. So from the data warehouse, currently we are doing ETL, if you guys are familiar. ETL is extract and transform and load. Moving to the data lakehouse approach is going to be pub sub, so publisher and subscriber. So instead of me actively pulling data from a source and storing it into my storage, for the lakehouse approach, it's more like Facebook or YouTube, wherein I post something. So I post a data. If you're subscribed to me, you're probably going to see it. It's up to you whether you consume the data or not. This way, the data actually flows a bit more real time. So that's what we're doing for the single clean source of truth. Now talking about data analytics. So data analytics is more of the science of analyzing raw data to make conclusions about that information. That's the definition in the basic sense. But there's actually more dimensions to data analytics than just analyzing raw data. And in fact, it's often interchanged with data science these days. So I'm just gonna go through the 4 types of analytics. I don't know if this was discussed in your prior session for IIBA, but at least for us in the insurance space, we're working with 4 types that we know of. So there's the descriptive analytics, diagnostic, predictive, and prescriptive. So for descriptive analytics, it's more focused on what? What did our customers buy? What happened that day? What was the event? So it's more just describing the what. You're just describing something. When it comes to reports, it's going to be how much did we sell? So like, what did we sell? We sold 10 million units of this item. So it's just explaining what happened. And then from there, you can move up to diagnostic analytics. Why did it happen? Why did our customers buy? So if in the descriptive report, it shows that we sold 10 million of, say, life insurance, the question now is, why did we sell 10 million of this? Why did the people want it more than the previous month? What happened from between, let's say, first quarter to second quarter? We're now trying to analyze retroactively what happened. So, we understand why it happened so that maybe we can replicate it into the future. And then the next type is predictive. It's more now, as the name states, trying to predict what's going to happen next. So now we know why the customers bought this product of ours. What will our customers buy next? What will they be interested in next? What will happen? When will it rain? When will we reach our targets and so on? And this is particularly important for insurance because for us, we sell you a promise. We sell you a promise that you will be protected with the policy that we have, so that if the event that you're insured against happens, you're guaranteed a certain amount to help you move forward, move across that bump in your life. And if we cannot predict reliably when you guys will be needing the money, then if everyone claims at the same time, the company just shuts down because we won't have enough money to pay out. So we are particularly keen on having predictive analytics. And we've had some form of this using statistical models for the past few years, but it's something that we're working towards to automate, to add machine learning and maybe AI in the future, so that our predictions will be reliable to serve our customers better. And then the next step from this, you think, okay, you've described what happens, you've analyzed why it happened, and now you predicted what happens next. What could be more than this, right? So we also have prescriptive analytics. It's more now delving into that space of how can we actually influence people? How can we actually influence the outcome? It's not just now predicting when it will rain, but also how do we make it rain? How do we make sure that on these dates it actually rains? So we are experimenting on this part right now. That's why we are hiring people from various analytics and data science driven companies so that we ramp up our efforts. But yeah, these are the 4 types of analytics that at least we know of so far. I know there's mentions of, AI analytics and other rogue forms. But for now, these are the 4 more established ones that we are working with. So with analytics in mind, there was actually a question on our end. Like there has been this conversation of being data driven. It's a common thing that's that I personally experience in, like, even in IBM and my prior companies. There's a question of how do we make ourselves data driven, and then there's this rising trend of the term data led, wherein it tries to look at the picture from a different angle. So what's data driven and data led? Data driven is where the machine provides you the insights, you prepare the data, you prepare the analytics. The humans do the analysis and the data pushes the people. So the machine says, okay, this is what Manu likes, right? This is what he likes. Me as the agent, when I see that, okay, it's up to me whether I trust the machine. Like if the machine says Manu likes cars, maybe I could sell him car insurance. It's up to me to decide that, okay, maybe not. I know Manu personally, or maybe I know Manu already has car insurance, so probably doesn't need it anymore. But data driven is like that. We are driven by the data to make decisions. Now, the other side of the fence, when it comes to analytics, is being data led, in that the machine provides the insights, but now we, the humans, trust the AI to decide. And then the data pulls the people. So like this is, YouTube, Facebook, wherein the machine decides what to show you based on your preferences. Spotify, Netflix, it's not always perfect, but then you have to just really choose the use cases where not perfect is acceptable. When you think about it, it's there's no right or wrong answer with these two. These are 2 competing approaches, but what we have decided on, at least for the company that I'm working with right now, is that you can actually have both. Because while some say being data-led is the future, machines still lack the human common sense to determine whether data is clean, whether it's reliable before making key decisions. Whereas if we always rely on people, it's just going to be slow. Imagine if YouTube took, 15 minutes or 20 minutes before it gives you a recommendation, right? It's not going to be useful at that point. There's a need for the human element, but you choose the use cases where you really think the human element is important, because not only will that be slow, there's actually human bias that can cause human errors as well. So in a perfect world, hybrid approach is the best. But for us in AXA, we decided to go with a data-driven approach first. And the reasoning for this is that, as mentioned, we're still building our single source of truth. So the data is not yet at a point where it's clean enough, where the maturity of the data is reliable. So we really need the human element to make decisions first. And then once we get to a stage of maturity where we're confident with our data, that's when we will try to go for the hybrid approach and do more in the data-led space. Data-led space being more on prescriptive and predictive analytics. That's all I really have for today. I don't know if any one of you has any questions. I don't know if I'm even cohesive in my topic, but I can open up the floor for a few questions, or I can pass you on to Orly for the next discussion, more focusing on how he became a data scientist. So I see something on the chat. So yes, prescriptive analytics. So there's a question in the chat from EJ, by the way, and the question is predictive type of analytics similar to an application of behavioral science? And it actually involves a bit of that. So it's not just you now being the technical guy trying to predict what happens using statistics. You're actually involving people now, involving the business more on what trends we can teach the machine so that it can look at patterns. It can look at, as mentioned by you, behavioral science to influence customers. So yes, that's a well thought of question. Okay, I think that's all the questions from the folks. So I'll pass you on now to Orly. Orly, if you can prepare your presentation, please.
Right. Thank you, Sam. Let me just prepare my screen. All right, this one. Yeah, can you guys see my screen?
Yes.
All right. Hi, good evening. I'm Orly. As Manu and Sam have mentioned, I'm a data scientist and I'm working with Sam right now at AXA. So, right now I want to share with you my experience on how I became an engineer. I mean a data scientist from an engineer, a chemical engineering background, with my personal touch and uh, what to expect from this talk. I guess these are the contents. Probably I'll introduce a short introduction about myself. Who am I? And then I'll just explain to you how I managed to go from an engineering background towards a uh, data science domain. So the steps that I did in the past to become a data scientist. And then probably I'll open the floor for questions and answers if you want to know more of how I did it. So some inquiries about the journey that I've made, right? So again, I'm Orly Revalo. So I am an engineer and I graduated chemical engineer and then I'm a data scientist. I'm an avid learner actually. I want to learn a lot of things from business, from economics, psychology, and whatnot. And I'm a bookworm as well. So most of the things that I read is more on self-development. Psychology is the one that I'm really interested with most. And then fitness, I guess, as well, and nutrition. So anything under the sun that's really uh, piques my interest. So that's what I really do for that's what I am. So I'm also a fitness enthusiast. So I also go to the gym to make myself mentally and physically what healthy as well. So I graduated. So my educational background. So I graduated at University of Santo Tomas with a bachelor's degree in chemical engineering, and then after some time I started um, uh, learning. I mean, for applying for a master's degree in UPD, University of the Philippines, as a MS Industrial Engineering, major in operations research. So are you familiar with operations research? So for everyone, so operations research is about mathematical modeling, more on optimization. So you're like abstracting a real scenario into a mathematical model. So that is really mathematics, hard on mathematics, linear algebra, and statistics. So my work experience, so I started as a technical support engineer. So I was supporting the projects team situated here in the Philippines, but we're supporting projects in Southeast Asia and Taiwan. Most of our projects are in Singapore, so we're delivering pipelines, flow meters as well. And then after that stint, I become a production supervisor in a glass manufacturing plant. So I was the one creating the formulation for float glasses. So the industrial scale ones, the ones that you see in the buildings, the glass that they need. So we call those float glasses. So that's what I did as a production supervisor back then. And then after that, I've become a lecturer. So I was teaching engineering and IT students, engineering sciences, algebra, chemistry, physics, analytical geometry, and a lot different more. So environmental engineering as well. So from my experience, I've already done different fields, from an office, and then from production, and then an academe as well. And then from all those experiences, I realized that data, as we all know, is one of the most lucrative for this century. So I've tried researching, and then I tried researching about being a data scientist. So I started with understanding what a data scientist is, and then how to become one with that. So before I share with you my experience, I guess I need to um, like as Sam have mentioned. So try to have a data analytics in a practical sense. So have you ever wondered when you have used analytics in real life? So for example, are you familiar with elevators? So I guess you're familiar with elevators, right? So whenever you're taking lunch, especially for those high-rise buildings, um, you always realize that when you go out at exactly 12 noon, the queue, or the time it takes for you to take your lunch or whatever, or snack, or I mean lunch, 12 is not lunch, takes you a long time. So from day-to-day activities, you've already realized that when you're going for lunch at 12, um, you would take a lot of time. You would consume a lot of time in the elevator. So in that sense, when you're when you want to mitigate that, you want to uh, rather than go at 12 noon, you'd rather go before 12 noon or around 11, or just rather bring your own lunch. So that's data. From there on, you use and informed decisions based on the experiences you have in the past. So that's data analytics. Another example is when you go to the office, or you're going to work. So the weather forecast tells you you can total, kind of predict how long your travel would be. So based on your previous experiences, those experiences dictate your decisions, and then that's you can predict how long your traffic would be based on those conditions. And that's data analytics in action. So that's in the practical sense. And that brings me to my point. So right now, data is the new oil. So raw data itself is not valuable. So valuable in itself, but rather its value is created when it's gathered quickly, completely, and accurately. So when you properly refine this data quickly, it becomes a decision-making tool for you, and which in some sense provides you an insightful information that allows companies, you probably, or us, to react to different market forces as well. And what did I take to be, what does it take to be a data scientist for, well, caveat in my experience? So first and foremost, must have a clarity of your goal. So you must be clear with what you're going towards into. And then secondly, you want to identify the gap in the skill sets that you're missing. So for example, for me, I started as an engineer. So I looked up in the internet. So what are the skill sets of a data scientist that I need to fill the gap with? Number one is programming. Number two, the domain knowledge, and so on. And then third one is we need to seek help or look for a mentor. So that, and then create a timeline for your goals as well, and then finally learn the tools. So first and foremost, I identify the skills and the gaps that I have. So number one is programming, so coding scripts and software development. I have like zero knowledge in programming. So what I did to fill this gap is to learn or read a book about Python programming, and then research about or watch um, on-demand videos about Python programming. So that's why I gathered the knowledge for programming. And then mathematics, I have good understanding of statistics and linear algebra in my master's. So the only insight or the only gap that I have there is more on the creation of the algorithms in terms of machine learning, and then data visualization and data wrangling. So you want to create a visualization. So from here, I used different libraries. So I try to learn Matplotlib, or if you're familiar, and then Plotly. So those kinds of visualization. And then the domain knowledge, I don't have any knowledge about the domain. So for example, in convolutional neural networks, so for image processing, as well as natural language processing. So I need to like ramp it up in order for me to understand that. Machine learning and deep learning as well. Creation of those algorithms in the under the hood, especially using different tools, and then the business acumen. So those are the gaps that I have. And then for me, to seek for, I seek help and I look for a mentor. So good thing for me that I have friends in computer science, friends who has bachelor's degree in computer science. So I seek help what technologies are needed. If they know someone who's a data scientist or a data analyst, what are the tools that they know? What are the programming languages that they need to understand? And from there, I took up their advice, and then gathered all those resources for me to learn. And then, of course, you need to create your own timeline. So I've created my timeline way back. So I made it very clear what are the topics that I need to learn in a 3 months time. In the next 6 months, what would be the skill that I need to understand and to learn. and I make it sure that it's really specific, it's measurable, so achievable, realistic, and time related. So everything's time bounded. So in my experience, I tried to learn Python in a span of 6 months. So I gathered all the resources that I need in order for me to know that. And then as I also tried to learn the libraries needed for a specific especially in data manipulation, you need pandas, those kinds of libraries. So I also gave myself a deadline for that. So everything's measurable, everything's documented. So you can see at the end of the day, at the end of the timeline, you can see the progress that you've created with yourself, and you'll see that I've achieved this, and I'm going towards data science, right? And then you need to identify also last, you need to identify the tools that you need. So these are just some of the tools that you need for it in order for you to be the data science. Well, it depends on what specialization you'll want to do in data science. So data science is a very broad field. Um, Most of the tools here are more directed to the machine learning, deep learning, and data visualization. So you have Python, you have Tableau, if you're familiar with Tableau. I think you've seen this, and then Matplotlib for data visualization, Excel of course, scikit-learn for machine learning, Apache Spark, big data, TensorFlow, Google Colab, and PyTorch are for deep learning frameworks, Jupyter Notebook for scripting programming. So these are just some of the tools that you need as a data scientist. So most of these tools have a fundamental grasp on. So um, for you, if you want to specialize towards data visualization, so probably one of the tools would be you'd learn more about that in a deeper sense or deeper level. And that's I like to end my presentation with a quote. So the best thing about the future is that it comes one day at a time. And actually, that's the pace at which you have to deal with everything. So not slower, not faster, and it's all possible as long as the goals are very clear that you set. The goals that you set will all be done in the end. So thank you. I guess before I end my presentation, I'd really love to be connected with you guys. If you want to take some advice from me or what specifics, anything under the sun. So this is my LinkedIn account. You can just scan it, and then that's my Gmail. So yeah. Any questions so far?
Are there questions from the group? You can write. You can
Yes.
direct your questions to either Sam or Lee.
All right. I've seen this question from Zen. So would love to hear how does a day in the life of a data scientist looks like? Okay. Here, how can I? So typically in a day of a data scientist, so you start with your work. So for me, I start my day with writing all the priorities in a notebook. So you've got all the details done. I mean, the task to be done in that day. Typically for a data scientist, we number one, so it depends. So if you are in the start of a project, so you're just creating or um uh proposing a project. So you need to understand, number one, what does the business needs? So you need to interview different people from different businesses if they really want that. So for example, we have this specific project in AXA, so we need to understand who will use this, what are the metrics, understand the process, and then from there, what are the data that they are using for that with that. So that's one part of being a data scientist. You need to understand what the business needs. Another side of the coin, yeah, for a data scientist is after you've gathered all the requirements from the business, you need to understand now or create or explore the data. So most of the tasks in being data scientist, you need to do exploratory data analysis. So those analytics, as Sam have mentioned, descriptive analytics, descriptive analytics as well. So you need to understand first what the data tells you in the lighter sense. And then from there, you can build on your algorithms, whether it would be regression, so regression or clustering and whatnot. So most of the task of a data scientist, I think, is about 80% or 90% most of the time is about data wrangling or data cleaning, cleaning the data in itself. And then the rest would be feeding the data into a model, creating the model, training the model. So that's around 10 to 20% of your time, because the libraries that you are already available when you're creating the model. You just need to call in the APIs for that. So that's another for a data scientist. And then finally, when you've all created these models, you need to, so you've created a model, so who will use it? So now the next question is, how will you explain those models that you've created to the business? So you need to have an explainer, you need to have like the model explainer, what specific features would give higher weight on a specific output. So for example, a good example is, for example, about years salary, let's say. So you have a salary, and based on that, based on your salary, I mean, based on the years of experience you have, as well as the number of years or education that you have, which among those two features can give a better explanation or give like an effect on the salary that you have? So how high your salary is. So basically, you need to have a model that can you can explain to the business that this specific feature, this specific, the number of years of studies can give 0.5x of the amount of your salary and so on. So that's at the cycle of a day, well, typically for a data scientist. So hopefully I give you like a glimpse of what we do as a data scientist. And I really like this question because it's really open-ended. Thank you, Zen. Any other questions so far? Any questions? Yeah, I really appreciate your question as well. Thank you, Zen. So if you have baka nahihiya, or if you have questions, yeah. And from EJ, what are the common impediments you encounter? All right. Oh, that's a very good, another good question. So impediments that you encounter. Okay, so for me, for my experience, one of the impediments that you encounter, one of the really the impediments that you encounter when you're working as a data scientist is, number one, I think, is that clarifying the requirements of the business in terms of what it can do. Sometimes the business just assumes that it's a machine learning. With this data, we can do that. So you need to pinpoint specifically the requirements, the specifications of the business in order for you to translate that into a working model. So that's one of the impediments. Another impediment would be sometimes when you run a model, it's just like the accuracy is really low. So if the accuracy is really low, or your model is not giving you a very high accuracy, so you need to go back to the business and understand what are the data that's missing. Sometimes the quality of data is not good, missing data. Sometimes the data is not enough for you to create a conclusive decision or conclusive model, so that the model can predict whatever you're trying to predict. So that's that's another. And lastly, I think an impediment would be explaining what the model does to the business, because sometimes the model is just a black box. So especially in deep learning as well as CNN, convolutional neural networks for image processing, computer vision, and then NLP. Those types of models are black boxes. And for the business to appreciate the value of a black box or a model, usually they don't understand what are the metrics that these black boxes do. In order for them to understand, you need to change this, change that, and whatnot. So those are the three. So number one, creating the business, understanding the business requirement with the specification. Secondly is yung data quality. And lastly, explaining the model to the business. Yes. Were there times that the business does not accept the findings of the data? Yeah, sometimes. A good example would be, let's say, when you a good example would be COVID. Let's say try COVID. So, well, not in insurance, but in other applications. For example, you have an X-ray of the lungs of, let's say, a suspected COVID patient. So after getting all, so you've collected a lot of data from different patients, X-ray video, images from different patients. You run that to a model, and then you find out that your accuracy is, let's say, of finding whether this patient is COVID positive or not, is, let's say, 70%. As a hospital, I won't accept that, because you're just you're endangering the people, whether, because 70% of the time, 30% of the time, you'd be predicting that the person is not COVID positive. You get my point? So it depends on what the business is. But for recommender systems, for example, like Netflix or YouTube, a 70%, 80% accuracy on the right recommendation for a specific person is acceptable, because the business use case is not really dire on health. So it depends on business use cases. So I hope I answered your question. EJ. Thank you very much as well. Thank you. All right. Last question before I hand the floor to Manu, if there is, or you can just PM me if you're shy.
Yeah. Just to add quickly to Orly's answer when it comes to, the business not accepting the findings of the data. It's actually quite common, and there's two sides of the coin. What Orly illustrated is where the data is really not acceptable, and in that case, that's fine. But what if you have actually the correct data and the business still doesn't accept the findings? I guess that's the more uh, problematic situation, right? And it really all boils down to how well you can prove your findings. The trainings that Orly mentioned would really help you in illustrating the data better, making sure that there's proper visual storytelling, data storytelling, so that they really understand. And if they don't, you just really have to keep pushing. And in most cases, as long as you can really illustrate why the data is what it is and make it clear enough, people will tend to just accept it and plan ahead on how to address the data that's being presented to them. So it's gonna happen a lot for sure. But you just have to arm yourself with tools to make it so that you can explain yourself better.
Thank you for that, Sam. Yeah, it typically most of the time, if you can't defend your model with against whatever the business is, that they won't really accept it. So you really need to be confident with your data, your findings in with your model when you're presenting to the business, right? All right. I think uh, I'll turn the page to, I mean, the floor to Manu. So again, thank you very much for your time, and I really appreciate sharing with me, sharing to you my experience as an engineer going towards to data science. So if you have other questions, you can just um, connect with me in LinkedIn or just email me in this email. So let's connect. All right. I leave the floor to you, Manu. Thank you very
Okay.
much.
Yeah. Maybe leave that on there for a couple of seconds to give people a chance to scan that QR code. Really cool presentation, by the way. I loved it. I loved all the animations, and it really tell a story well. So it goes to show that this is the right career, I think, for you.
Thank you, Manu.
And thank you so much to Sam as well. You guys make a really cool tandem. And at this point, I would really like to express our appreciation. I hope all of you are done adding Orly on LinkedIn, because I'm gonna share my screen now as I make this post. So first we are we're sharing a certificate of appreciation to Sam. And we look forward to working together with him again in the future. So thank you very much, Sam, and we hope to network and keep in touch.
Thanks as well for the opportunity.
Thank you very much for your time, guys.
Okay, and here we also have the same. Okay, so thank you both. That was really cool. Okay, and is there anyone else who has any last minute questions, either to the speakers or maybe to IIBA Philippines? Okay, if none, I'll let you guys go a bit early. Thank you so much for a great event. Really good topic, and looking forward to hearing more from you guys. And have a good rest of your evening.
Thanks, everyone. Bye-bye.
Thank you, everyone. Good evening.
Hey,
Bye-bye.
everyone. Happy dinner.
Yeah, happy dinner. Sige, Bray. Una na din ako.
Yeah, same here. Thank you.
All right. Bye.
Bye-bye.